Hello students, so we're going to cover two additional topics from chapter 11 that were not covered in the previous videos. So the two topics are IV push, and you can find the topic of IV push on pages 313 to 316. And in the ebook, the topic begins on page 314. Okay, likewise, we'll talk about titrated medications, and you can see pages 323 to 325 for more information. And in the ebook, the topic begins on page 324. So before we do our first example on IV push, let's read some information about what that is. Okay, so to infuse a small amount of medication in a short period of time, a syringe can be inserted directly into a vein, or a saline lock or heparin lock can be attached to an IV catheter. Okay, so you can see in the picture here, this is an example of an IV push. So for patients who have a primary IV line, the medication should be administered through the port closest to the patient. So that's what's going on in the picture here. The medication that can then be pushed directly into the vein. This route of medication administration is referred to as IV push, or IVP for short. So because the IVP flow rate is determined by the speed at which the plunger of the syringe is manually pushed, it is important to control that speed. It is difficult to maintain the desired flow rate over the entire infusion, so therefore the infusion may be mentally divided into smaller segments or pieces to make the flow rate easier to control. Okay, we'll talk more about that here and as we do the examples. Okay, so let's go ahead and take a look at our example. So this is just like exercise number 8. In chapter 11. So I went ahead and copied it, but I changed some of the numbers. Okay, so the example is similar, but the numbers are different. So that's the numbers that I changed here are in bold. Okay, so the example says we have an order for morphine sulfate, 5 milligrams IVP, so IV push, over 10 minutes. Okay, and the directions further state to dilute the medication with normal saline to 5 milliliters. Okay, then it says that the concentration in the morphine sulfate vial is 8 milligrams per milliliter. Okay, and there are 3 parts to the question here. Okay, so the first part of the question asks how many milliliters will be withdrawn from the vial. Okay, so it's important to realize that we have a vial just like this one that contains the medication. Okay, so the 8 milligrams per milliliter that you see here in the problem is just for illustration purposes. Okay, so this may or may not be a realistic concentration for morphine sulfate. Okay, so this is an example of a morphine sulfate vial. Okay, so it's a liquid containing the medication, and according to the label, the concentration is given as 10 milligrams per milliliter. Okay, but we're going to use the concentration given in the problem. Okay, so this is an example of a vial. Okay, so we're going to withdraw the appropriate amount from the vial first. Okay, so the first part is asking how many milliliters will we withdraw from the vial if the concentration is 8 milligrams per milliliter. All right, and the amount of the dose given in the order is 5 milligrams. Okay, so we're going to take the 5 milligrams. Okay, and multiply it by 1 milliliter. Okay, over 8 milligrams. Okay, so you're taking the concentration of the drug and flipping it over, okay, and multiplying it by the amount given the order, okay, and we eliminate the units of milligrams. Okay, so essentially we're taking 5 and dividing it by 8. Okay, and we can round that accordingly. So we get 0.625. So let's go ahead and round that to the nearest hundredth. So 0.625 rounded to the nearest hundredth is 0.63. So we're going to withdraw approximately 0.63 milliliters. 0.63 milliliters. Okay, will be withdrawn from the vial. Okay, so once we withdraw the medication from the vial, okay, it's going to go into a syringe. Okay, just like you see here. So this would be like a typical syringe you might use in an IV push application. Okay, and so what it says here, once we withdraw the amount from the vial, we're going to dilute the medication with 5 milliliters to 5 milliliters of normal saline. Okay. So in other words, so the 0.63 milliliters will go into the vial, go into the syringe, and then the needed amount of normal saline will go in to get 5 milliliters total. Okay. So the medication and then the normal saline go into the to the syringe, okay, for a total of 5 milliliters. Okay, so then the second part of the question says to find the flow rate, okay, in milliliters per minute. Okay, so the question is, right, how do we do that? Okay, so you're going to take the total number of milliliters and then divide by the number of minutes. Okay, so we know it's going to take about 10 minutes. Okay, it says 10 minutes. Okay, administer the medication over 10 minutes. Okay, but do we use the 0.63 milliliters? Okay, or the 5 milliliters? Okay, so since we're diluting the medication to get a total of 5 milliliters, okay, it's the total number of milliliters that are in the syringe, which is 5. So 5 milliliters, okay. So the flow rate would then be the number of milliliters divided by the number of minutes. Okay, so 5 milliliters. Okay, 5 milliliters. Okay, over 10 minutes, and then you're just going to simplify that as much as possible. Okay, so 5 divided by 10 is equal to 0.5. Okay, so basically half a milliliter will be administered every minute. So 0.5 milliliters per minute is the flow rate. Okay, so it is the flow rate, okay, of the IV push. Okay, so the last part of the question asks how many milliliters will be administered every 30 seconds. Okay. So you may remember a little earlier in the video, right, it says that it's difficult to maintain the desired flow rate over the entire infusion, okay, since you're doing this thing manually. Okay, so therefore the infusion may be divided, may be mentally divided into smaller segments or pieces to make the flow rate easier to control. Okay, so that's what this question is asking. Okay, so you're going to administer a certain number of milliliters every 30 seconds by moving the plunger of the syringe accordingly. Okay, so if you look at the examples here, so let's say for example that you are that 4 milliliters of solution must be infused in 1 minute, okay, which would be 60 seconds. So 4 milliliters over 60 seconds. So you can divide it into 2 segments, which means you would give 2 milliliters every 60 seconds, right? Or you can take that same flow rate, right, 4 milliliters over 60 seconds, and divide it into 4 segments. So in other words, you would give 1 milliliter every 15 seconds. Okay, so to answer this question, right, how many milliliters will we give every 30 seconds? Okay, well, first of all, right, how many seconds are in 10 minutes? Okay, right, so how many seconds are in 10 minutes. Okay, that's easy to figure out. Okay, so we can do a quick calculation. So 10 minutes, okay, multiplied by, okay, 60 seconds over 1 minute. So 60 seconds are in 1 minute. Okay, so using this approach, right, we see that in 10 minutes there are 10 times 60, or 600 seconds. So 10 times 60, 10 times 60. Okay, so 600 seconds are in 10 minutes. Okay, so therefore the flow rate can be expressed as, okay, the total number of milliliters, which is 5, so 5 milliliters over, okay, 600 seconds. Okay, so once again, I'm not saying that this is realistic, okay, but this is how you would approach it. Okay, so then how do we answer the question, right? So okay, we figured out how many seconds are in 10 minutes. So we rewrite the flow rate as 5 milliliters over 600 seconds now. Okay, so since we want to know, well, we want to know how much to give every 30 seconds, so we then take 600 and divide it by 30. Okay, we get 20. Okay, so in other words, we're going to divide. Okay, we're going to divide the top and bottom of this fraction by 20, and then simplify. Okay, so divide by 20, divide by 20. Okay, so 5 divided by 20 is 0.25. Okay, and then obviously 600 divided by 20 is 30. Okay, so we're going to give 1/4 of a milliliter, or 0.25 milliliters, every 30 seconds. Okay, so you might be asking, so what was the point of dividing by 20? Okay, so first of all, right, if we want to know how many milliliters to administer every 30 seconds, right, we figure out how many 30-second segments are in 600 seconds. Okay, so it's easier to convert 10 minutes into seconds. Okay, so basically, to figure out how many 30-second segments are in 600 seconds, okay, we divide that by 30 and we got 20. Okay, so then we take that 20 and then divide the top and the bottom of this fraction, all right, to get the number of milliliters what we'll give every 30 seconds. Okay, and they do a similar approach here. Okay, so they kind of explain it that way.